Emma is 3 years old. She lives in Europe and goes to nursery school. She's protected against several infectious diseases. Fanta is 3 days old. She lives in Africa and this is her first visit to the doctor. Thanks to the immunization campaigns organized in her country, she will soon be protected. Clara is 8 years old and she lives in Central America. Clara is at risk of catching dengue fever. Soon a vaccine will be available to protect her against this disease. 30 years from now, when Emma, Fanta and Clara are adults, their own children will be protected against still other diseases thanks to vaccines. But for now, that's far from their minds.
With the exception of clean drinking water, no scientific progress or technical innovation can rival with the impact of vaccines when it comes to fighting infectious diseases.
It's true. Vaccines protect lives every day. Today we have vaccines that protect against 26 different diseases. Around the globe, the lives of 3 million men, women and children are saved each year thanks to vaccines.
But how do vaccines work?
Regardless of whether they target viruses or bacteria, vaccines work by stimulating the body's natural defenses. The human body has an incredibly sophisticated defense system, the immune system. It's an internal army made up of millions of different kinds of soldier cells, lymphocytes, macrophages, and specialized molecules such as antibodies. This army has a very specific job to do: locate and destroy any infectious agent that enters the body. The better the immune system knows the enemy, the better equipped it is to fight it. This is the principle on which vaccination is based. Vaccination is a matter of teaching the immune system to identify the infectious agent in order to neutralize it. It is also a matter of refreshing the immune system's memory, so that in the future it will be able to recognize viruses and bacteria.
So the enemy is allowed to come inside in order to teach the body to defend itself?
Exactly, but certain precautions are taken, like disarming it. During vaccination, a bacterium, a virus, or one of the substances they produce is injected into the body. But first they are weakened sufficiently so they will not be able to cause disease. At the same time, they must remain antigenic, which means they're still able to induce a protective immune response. There are 3 major categories of vaccines. Live attenuated vaccines contain living microorganisms that have been attenuated or weakened. The oral polio vaccine and the measles, rubella, mumps and yellow fever vaccines all fall into this group. Inactivated vaccines are made using microorganisms that have been inactivated or killed during the manufacturing process. This category includes vaccines to prevent influenza and pertussis. Thanks to genetic engineering, new technology enables scientists to design what are called recombinant vaccines, such as the hepatitis B vaccine.
So vaccines are made from microorganisms?
In fact, they're made using microorganisms that have been attenuated or inactivated, or fragments of microorganisms. They also contain substances, so they'll remain potent and not change over time.